Right, we've looked at factorising quadratics, and one way we can use the factorisation is to simplify algebraic fractions. I've got two examples here that I'm going to do. So for the first example, the best way to simplify an algebraic fraction is to break it down into things that multiply to make each of the expressions, the numerator and the denominator. And the way you can do that with quadratics is by factorising into two brackets. So what we're going to look at is the factorised version of x squared plus 5x plus 4 and x squared plus 8x plus 16. And we're going to just rewrite this fraction in factorised form. So to factorise the numerator and to put it into two brackets, well, because it's an x squared on its own, I know I must have an x and an x in my bracket, so that when I multiplied these out, I would get my x squared. I also want two numbers in here that multiply together to make a plus 4. So that would be 1 and 4, or 2 and 2. Okay. They must also, these two numbers, this pair of numbers, whichever pair it is, must add to make a 5, a plus 5. So they multiply to make plus 4, they add together to make plus 5, surely it must be 1 and 4. Okay, so it's plus 1 and plus 4. So on the bottom, let's look at the denominator now, x squared plus 8x plus 16. Going to put it into brackets, must have two x's in there. Two numbers multiplied together to make 16, but add together to make 8. Well, let's have a look at that. 1 and 16, 2 and 8, 4 and 4. They add together to make 17, they add together to make 10, they add together to make 8. So therefore this must be, and it may add together to make a plus 8. So therefore it must be plus 4 and plus 4. Now that we have it in factorised form, we can cancel out common terms. Okay, we can only do this when everything's being multiplied. We can't do it if there's an additional, if let's say there is an addition there somewhere at the end. Okay, it can't be cancelled out unless everything on the top and everything on the bottom is being multiplied. Okay, so x plus 4 will cancel out with x plus 4, and we're left with x plus 1 over x plus 4. And that's the simplification of an algebraic fraction. Okay, the second one's a little bit harder because we've got numbers in front of the x squared. But we have seen how to factorise a quadratic where we have a number in front of the x squared. Okay, so that's what I'm going to do with this one. So let's start with 3x squared minus 4x minus 4. And I want to write this as a factorised version. Okay. So we start by doing 3 times minus 4. Okay, 3 times minus 4 equals minus 12. And then we look for the numbers that multiply to make minus 12, but add together to make minus 4, the number in front of the x. Okay, so we got 1 and 12, 2 and 6, 3 and 4. Well, it's got to make a minus 12, so one of these numbers has got to be a minus. And they've got to add together to make a minus 4. So therefore I think it's got to be a minus 6 and a plus 2. Okay, none of the others have a difference of, or if you were to add them together, would make minus 4. So right, what we do next is we write 3x squared minus 4x minus 4 as something else. So let me do this over here beforehand. So we take the 3x, and that's going to be part of one of our brackets, and the 3x is going to be part of the second of our brackets. We've got a plus 2 and a minus 6, and then we divide through by 3. Right, what do we get? Do either of these brackets divide through by 3? Yes, the second one. So we can divide the second one to get x minus 2. So we get 3x plus 2, x minus 2. So I had to divide it by 3. So this numerator quadratic can be written as 3x plus 2 x minus 2. Alright, so that's the first bit. Let's do the second bit. I need to factorise 12x squared plus 5x minus 2. Okay, so we've got 12x squared plus 5x minus 2. So the first thing we do is we do 12 times minus 2. So 12 times minus 2 equals minus 24. Numbers that multiply to make minus 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. One of these has got to be negative to make a minus 24, and the other one's got to be positive. So they've got to add to make plus 5. It wouldn't work with 1 and 24, wouldn't work with 2 and 12, it wouldn't work with 4 and 6, but it would work with 3 and 8. But it would have to be a minus 3 and a plus 8. Okay? So over here, we're going to take the 12x out of the question and put it into both brackets. And we're going to put in the minus 3 and the plus 8. And then what we need to do is divide by 12, because 12 is the number in front of the x squared. So 12 doesn't go into either of these brackets, but if I broke this up, 3 would go into the first bracket and 4 would go into the second bracket, because 12 can be written as 3 times 4. Okay? So 3 is going to go into the first bracket, and that's going to leave us with 4x minus 1. And in the second bracket, we're going to divide both 12 and 8 by 4. We get 3x plus 2. Okay, so 12x squared plus 5x minus 12 can be written as these two brackets in a factorised version. I know it seems like a lot of work, but it's the only way to do this, really. So, taking the original fraction, I'm going to replace the numerator with this factorised version here, and replace the denominator with this factorised version here. Okay, so we've got 3x squared minus 4x minus 4 divided by 12x squared plus 5x minus 2 equals 3x plus 2 x minus 2 divided by 4x minus 1 3x plus 2. And now we're going to look to see whether there's anything similar that we can cancel. Okay, so there's a 3x plus 2 in both numerator and denominator, so they can be crossed out. Nothing else is the same, so our simplified fraction is x minus 2 over 4x minus 1, and that's your answer. Okay, the second example is pretty tricky. I'd definitely like you to have a go at the first example kind of questions. Alright, once you're happy with those, I suggest you don't waste any more time on that and you move on to the second style of questions, because they are the tricky ones. There are lots of other different variations, some that you will see before you get to your year 11 exams. So have a go, do your best. The answers are there, so I'm sure you'll do just fine.